Hi everyone, today we made a video about basic chromatography. First, this is our teammates. We have 3 members.
So now, let's move to the contents. 1. Introduction. 2. Explanation. 3. Conclusion. And 4. References. Now, let's move to the introduction.
First of all, introduction. Chromatography is a simple yet powerful technique used to separate the components of a mixture. It works by exploiting differences in how substances interact with the stationary and a mobile phase. From analyzing pigments in ink to purifying medicines, chromatography is essential in many scientific and industrial applications. In this video, we will introduce its principles, basic types, and uses. Chromatography is important because it allows us to separate and analyze mixtures, which is crucial in many fields. In pharmaceuticals, it ensures drug purity and safety. In environmental science, it helps detect pollutants. It's also used in food testing to identify additives and contaminants. Without chromatography, many advancements in chemistry, biology, and industry wouldn't be possible.
Theory. Chromatography theory is based on a dynamic equilibrium between the stationary phase, solid or liquid, and the mobile phase, liquid or gas. When a combination moves through the system, components that have a higher affinity for the stationary phase move slower, while components that have a higher affinity for the mobility phase move quicker. The next one is principle. Stationary phase is a stable material or surface that preserves mixture components based on their chemical or physical qualities. Consider silica gel in thin layer chromatography or a liquid coated column in gas chromatography. Mobile phase is a liquid or gas that transports the mixture's component through the stationary phase. For example, solvent mixture in HPLC or carrier gas in GC. The last one is mechanism. Adsorption in chromatography, components adhere to the stationary phase surface. For example, in TLC, analytes adsorb onto the silica surface. So the next one is chromatography in forensic science. Chromatography is a crucial analytical technique in forensic science for identifying and separating chemical components in complex mixtures. Its ability to isolate substances makes it invaluable in criminal investigations, toxicology, and drug analysis. Chromatography is commonly used to detect and identify drugs in biological samples such as blood, urine, or hair. It helps detect poisons, alcohol, and other toxic substances in tissues, blood, or other biological samples. The last one is chromatography is used to analyze environmental pollutants or toxins at crime scenes like soil or water contamination. The technique used in forensic chromatography. The first one is gas chromatography GC, suitable for volatile and thermally stable compounds. Second one is high performance liquid chromatography HPLC, ideal for non-volatile, thermally unstable or polar substances. And the last one is thin layer chromatography, a simpler method often used for preliminary tests, for example, identifying drugs or inks. So, beside the sentence, you can see the example for the gas chromatography, the picture, and also the high performance liquid chromatography, the type of the machine that they use. The next one is going to talk about the application of thin layer chromatography in forensic. As the forensic operates, a range of evidence is uncovered at the scene, either polluted or collected in pure form. Evidence discovered to be tainted must be evaluated by fragmenting existing components. Hence, TLC is the ideal method for categorizing the numerous components that exist in the organization. For example, TLC can be used to identify and compare drugs. Preparation of the plate. A TLC plate coated with silica gel, stationary phase is used. Sample application, small spots of the unknown sample and reference standards. For example, cocaine, heroin, amphetamines are applied near the base of the plate. Mobile phase, a solvent mixture, example methanol and chloroform, is used as the mobile phase. Development, the plate is placed in a TLC chamber with the solvent. The solvent moves up the plate, carrying the components of the samples. Visualization, after development, the plate is air-dried and visualized under UV light or treated with a chemical reagent, for example iodine or ninhydrin spray, to reveal the spots. So we're gonna move to the example of the result. From the result, we can see that the unknown sample, we get the RF value of it, and from the RF value, we can see that the sample's RF value is the same as the cocaine RF value. So from this, we can indicate that the unknown sample is cocaine. And the last one is significance of TLC in forensic. Quick identification. TLC provides a fast and inexpensive way to preliminarily identify substances. Comparison with standards, matching RF values confirms the identity of the substance. And the last one is court evidence. TLC results can support further confirmatory tests and provide evidence in legal proceedings.
In conclusion, chromatography is a powerful technique for separating and analyzing mixtures. By utilizing difference in the component's ability to travel through a stationary phase, it allows us to identify and quantify substance in complex mixtures. Whether in labs or industry, chromatography is essential for ensuring purity, quality, and accuracy in various fields such as chemistry, biochemistry, and pharmaceutical.